UGC NET Electronic Science June 2025 question paper solutions part 5, that is from question number 101 to question number 125. Question number 101, match the list 1 with list 2. A graphene. In graphene, each carbon atom undergoes sp2 hybridization, forming 3 sigma bonds with neighboring atoms in a hexagonal lattice structure. So graphene is sp2 hybridization. Carbon nanotube. Chirality in carbon nanotube refers to the twist or angle at which the graphene sheet is rolled up to form the tube, designated by the chiral indices m, n. So carbon nanotube is chirality. B matches to 1. C is zinc oxide ZnO. It is having wide energy band gap and high transparency, around 3.3 electron volts is a band gap, used as transparent conducting or optical material. ZnO, zinc oxide, wide band gap and high transparency. Next is silicon carbide SiC. It is having high thermal conductivity. Silicon carbide D matches to 2. A3, B1, C4, D2. Correct answer is option 2. Next question. Arrange the given power amplifiers in the order of increasing power efficiency. So class A amplifier, class AB, class B, class C and class D power amplifiers. We know that the maximum efficiency of class A power amplifier, if it is series fed class A power amplifier, is 25%. Series fed power amplifier is 25%, whereas transformer coupled class A power amplifier is 50%. The maximum efficiency of class B is 78.5%. Maximum efficiency of class C power amplifier is 90%. The efficiency of class AB power amplifier, it is higher than class A and less than class B power amplifier. Efficiency of class AB lies in between A and B. For correct sequence of increasing order is class A, class AB, class B, class C, class D. Correct answer is option 3. Question number 103. The main advantages of SMPS over convolutional linear power supply is statement option 1. SMPS has lower output ripple and its regulation is superior. It is incorrect because linear power supplies have lower ripple and better regulation. SMPS have higher ripple and switching noise. Here it is higher output ripple for SMPS. Option 2. SMPS is a source of both electromagnetic and radio interference due to high frequency switching. So option 2 is, it is not an advantage, it is disadvantage. SMPS is a source of both electromagnetic and radio interference due to high frequency switching. It is a disadvantage. Option 3. SMPS is less sensitive to input voltage variations and it is small in size, lighter in weight for same power rating. Option 3 is correct. Option 4. SMPS requires the usage of filters on both input and output to control radio frequency noise. Option 4 is also correct, but it is not an advantage, it is disadvantage. Therefore, correct answer is option 3. The advantages of SMPS are small, lightweight, high efficiency, works well with the input voltage variations due to switching regulations. These three are the advantages of SMPS. Next question. The transmission efficiency of amplitude modulated wave is given by. Transmission efficiency is the ratio of power in sidebands to total power, whereas total power is sum of carrier power plus upper sideband power plus power in lower sideband. That is, total power PT is equal to PC plus power in total power in the side bands. Efficiency is power in side bands to total power into 100 if it is percentage efficiency. Correct answer is option 1. Question number 105. A straight line is seen to result form a plot of 1 by C cube versus V, where C is capacitance and V is voltage. What does this imply about the doping profile shape? We know that depletion capacitance, transition capacitance, or reverse bias junction capacitance Cj is directly proportional to 1 by V power n, or Cj is equal to V power minus n. Cj proportional to V power minus n, where V is the applied reverse bias voltage. Here n is equal to 1 by 2 for step graded junction, 1 by 3 for linear junction, 1 by 2.5 for diffused PN junction. In the question they have given 1 by C cube versus V plot. That is, it is a linear graded junction. Option 2 is the correct answer. Question number 106. A step index fiber in an optical fiber with, we know that refractive index is uniform at the core and undergoes abrupt change at the cladding boundary for a step index fiber. Core refractive index is uniform and on the cladding with slightly lower refractive index. Correct answer is option 1. Refractive index is varying. Core refractive index is varying. Option 2 is incorrect. Refractive index of core and cladding are same. Incorrect. The ratio of refractive index is 1. It is also incorrect. The correct answer is option 1. Question number 107. Which of the following statements are true? This question is related to regions of operation in MOSFET. MOSFET has 4 different regions of operation. One is ohmic region, saturation region, cutoff region, and breakdown region. This ohmic region or triode region or linear region, in this region MOSFET acts like a voltage controlled resistor. In saturation region, MOSFET acts like an amplifier. In cutoff region, it acts like a off switch. Statement A MOSFET is biased in saturation region for amplification applications. Statement A is correct. Statement B, MOSFET is biased in linear region for amplification applications. In linear region or triode region or ohmic region, MOSFET acts like a voltage controlled resistor. Statement B is incorrect. Statement C, BJT is biased in saturation region for amplification applications. The regions of operation for BJT is in saturation it acts like an on switch, in active region it is amplifier, in cutoff region it acts like a off switch. Statement C is incorrect. Statement D, BJT is biased in active region for amplification applications. D is correct. Statement E, MOSFET is biased in saturation region for realizing a resistor. For realizing a resistor, it has to be operated in ohmic region. Statement E is incorrect. Therefore, correct answers are statement A and D. Option 3 is a correct answer. Question number 108. Arrange the following programmable logic devices in the order of increasing complexity of their architecture. PAL, programmable array logic. It is having fixed R array plus programmable AND array. Next, SPLD, simple programmable logic device. CPLD, complex programmable logic device. So this complex programmable logic device is a combination of several SPLDs connected through a programmable interconnection matrix. Next, FPGA, field programmable gate array, an array of configurable logic blocks plus programmable interconnects plus embedded resources. Here least complex is PAL, followed by SPLD, then CPLD, and then FPGA. FPGA is most complex. Therefore, increasing order of complexity is A, B, C, D. Correct answer is option 1. Question number 109. Arrange the following technologies in terms of decreasing noise margin. We know that noise margin is amount of noise voltage that a digital circuit can tolerate or reject with performance getting unaffected. So the noise margin for RTL resistor transistor logic is 0.2 volts, for ECL 0.3 volts, for TTL 0.4 volts, for NMOS it is 1.5 volts, for CMOS noise margin is half of supply voltage. Here noise margin is highest for CMOS and lowest for ECL. So CMOS is C and ECL is A. The correct answer is option 3. Noise margin of CMOS less than NMOS less than TTL less than ECL. Question number 110. The condition for symmetry obtained from Z parameters is, for Z parameters, condition for symmetry is Z11 is equal to Z22. For Y parameters or short circuit parameters or admittance parameters, condition for symmetry is Y11 is equal to Y22. For transmission parameters or ABCD parameters, condition for symmetry is A is equal to D. And for hybrid parameters, condition for symmetry is delta H is equal to 1 or H11 H22 minus H12 H21 is equal to 1. Here the correct answer is option 1. Next question. The maximum power will be delivered by a network to the impedance ZR if the impedance ZR is. So this is related to MPT, maximum power transfer theorem. It states that AC voltage source will deliver maximum power. AC voltage source will deliver maximum power to the variable complex load only when the load impedance is equal to complex conjugate of source impedance. So correct answer is option 4. When this load impedance is equal to complex conjugate of source impedance. Suppose if it is a DC voltage source will deliver maximum power to the variable load resistor only when load resistance is equal to source resistance. Question number 112. The instruction AAA is used to ASCII adjust after addition. It is ASCII adjust after addition. So correct answer is option 2. This AAA instruction is used for adding two ASCII coded decimal digits. It adjusts the result so that it becomes a valid unpacked BCD. So how the operation is, initially it checks lower nibble of AL register and auxiliary carry flag. If lower nibble is greater than 9 or auxiliary carry flag is carrying 1, then it adds 06 to the AL and 01 to the AH, so that AF is set to 1 and carry flag is set to 1. Else AF is 0, carry flag is 0. Question number 113. What logic function can be implemented by the following circuit? So here two inputs are connecting at point Y. Here it is A, B bar, it is A bar, B. So Y is equal to AB bar plus A bar, B. It is nothing but XOR of A comma B. Correct answer is option 3. This logic function acts like a XOR gate. Next question. Match the list 1 and list 2. So in list 1, microcontroller is given. Correct answer is 8051. So 8051 is a microcontroller. 8051 is a classic microcontroller with built-in RAM, ROM, IO ports and etc. Next 8086. 8086 is a 16-bit microprocessor with 6-byte prefetch instruction queue. B matches to 1. Next, DMA controller Intel 8257 is a classic direct memory access controller designed to offload data transfer tasks from the CPU. So DMA is 8257. Programmable interrupt controller 8259. 8259 is a programmable interrupt controller designed to enhance the interrupt handling capabilities of microprocessors like 8085 and 8086. So D matches to 3. A4, B1, C2, D3. Correct answer is option 3. Next question. What is the frequency of waveform or the Q output in the given circuit? So the given circuit has only one flip flop. So small n is 1. So the number of states is 2 power 1. The total number of states is 2. Now the output frequency is input frequency to the number of states. It's a ratio of input frequency and number of states. Now output frequency is input frequency. Input frequency given in the circuit is 10 kilohertz. So 10 kilohertz divided by total number of states, it is 2. So answer is 5 kilohertz is the output frequency. Correct answer is option 1. Question number 116. A silicon diode has saturation current of 5 nanoampere at 25 degrees centigrade. What is the saturation current at 95 degree centigrade? We know that reverse saturation current doubles for every 10 degree rise in temperature. And the equation is IO2 is equal to IO1 2 power T2 minus T1 by 10. Here IO1 is 5 nanoampere 2 power T2. Temperature T2 is 95 degrees. Temperature T1 given is 25 degrees divided by 10. That is 5 nano into 2 power 95 minus 25. It is 70 divided by 10. So 5 nano into 2 power 0.2 power 7. 2 power 7. So 2 power 7 is 128 into 5 nano, that is 640 nano ampere. This reverse saturation current at 95 degrees centigrade is 640 nano ampere. Correct answer is option 3. Next question. Choose the correct option for a thyristor. So it is a PNPN semiconductor device. So this thyristor has 4 layers, 3 junctions and 3 terminal device. It is having 3 junctions J1, J2, J3, 4 layers P1, N1, P2, N2 and 3 terminals anode, gate and cathode. So statement A is correct. Statement B, it is a 3 junction semiconductor device. Statement B is correct. Statement C, when anode is positive with respect to cathode, it is in forward blocking mode. So there are 3 modes of operation for this thyristor. One is forward blocking, forward conduction, reverse blocking. In forward blocking, anode is positive with respect to cathode. Statement C is correct. See the statement E, when and cathode is positive with respect to anode. When cathode is positive with respect to anode, it is in forward blocking mode. Statement E is contradiction of statement C. It is incorrect. Statement D, when cathode is positive with respect to anode, the switch open is reverse blocking mode. Statement D is correct. So correct answer is option 4. A, B, C, D statements are correct. See some more points related to thyristor. Forward blocking mode, anode is positive with respect to cathode and gate is off. So J1 is forward bias, junction J2 reverse bias, J3 is reverse bias, and the behavior of silicon control rectifier is off state. In forward conduction mode, anode is positive with respect to cathode and gate is on. Junction J1 is forward bias, J2 is forward bias, J3 is forward bias, and SCR acts like a on switch, allowing current to flow. In reverse blocking mode, cathode is positive with respect to anode. Junction J1 is reverse bias, J2 forward bias, J3 reverse bias. Silicon control rectifier is off. Question number 118. Which of the following statements are correct? Flip-flop may be referred as bistable multivibrator. The other name for bistable multivibrator is flip-flop. Statement A is correct. Statement B. A maximum of 2 power n logic functions can be implemented with n variables. Statement B is incorrect. We can able to implement 2 power n logic functions with n variables. Statement C. It is related to dynamic hazards. Dynamic hazard may occur in asynchronous sequential circuits. C is correct. So dynamic hazard occur in asynchronous sequential circuits as well as in multi-level combinational circuits. When the output changes several times, then it should change from 1 to 0 or 0 to 1 only once. It is called dynamic hazard. This dynamic hazard occur when the output changes for two adjacent input combinations while changing. The output should only change once. Statement D. Static hazard may occur in synchronous sequential circuits. Statement D is incorrect because static hazard is a momentary unwanted fluctuation or a glitch in which the output of logic circuit due to different path delays. Static hazard occur in combinational logic circuits and it is more common in asynchronous circuits. And this static hazard is of two types: static 1 hazard and static 0 hazard. So here asynchronous. So synchronous is incorrect. Statement E. Hardware description language HDL is used for analog circuit design entry. It is incorrect. HDL is used for digital circuits. This hardware description language is a computerized specialized computer language used to describe, model, and simulate digital electronic circuits. This HDLs mainly used for digital circuit design entries such as logic gates, flip-flops, counters, processors, digital systems on FPGA or ASICs. Common HDLs are VHDL, Very High Speed Integrated Circuit Hardware Description Language, Verilog HDL system, Verilog. So correct statements are A and C, and the correct answer is option 4. Question number 119. It is related to H parameters. Output admittance with input open circuited. So input is open circuited. H11 is input impedance with output short circuited. Here output V2 is short circuited. H1 is input impedance. H12 is reverse voltage gain with input open circuited. Reverse voltage gain with input open circuited. H21 is forward current gain with output short circuited. Forward current gain with output short circuited is H21. Therefore, correct answer is option 1. A1, B2, C3, D4. Question number 120. The schematic of CMOS inverter is. This CMOS inverter is a fundamental digital circuit that uses series of two complementary metal oxide semiconductor field effect transistors, two complementary MOSFETs to perform NOT logic gate function. It consists of one PMOS transistor connected to the power supply. PMOS is connected to the power supply, and one NMOS transistor connected to the ground. If input voltage is high, if this input voltage is high, NMOS is off, NMOS is on, PMOS is off, connecting output to the ground. Therefore, output is 0. If input is low, output is high. This is a circuit diagram. A is the input, Y is the output, PMOS is connected to VDD, and NMOS is connected to ground. Correct answer is option 2. CMOS inverter is option 2 circuit diagram. Question number 121. In list 1, transfer function is given. In list 2, step response is given. We need to match the transfer function with the corresponding step response. CA, we know that standard form of second order characteristic equation is s square plus 2 zeta omega ns plus omega n square is equal to 0. In A, characteristic equation is s square plus 25. So from this, omega n is 5 radian per second and zeta is 0. Zeta is 0 means it is undamped system. For undamped system, the step response is having oscillatory response. Oscillations exist. Next, C D. For D, zeta is 1 by 2 greater than 0 and less than 1, which is an underdamped system. It is an underdamped system. Underdamped system. Its step response is matches to second option. Second one. For B, zeta is greater than 1. It is overdamped system. For overdamped system, the step response is 3. For C, zeta is 1. Critically damped system. Critically damped because here zeta value is 1. Its unit step response is matches to 1. Therefore, correct answer is A4, B3, C1, D2. Correct answer is option 2. Question number 122. Stand VSWR, voltage standing wave ratio. It is 1 plus tau by 1 minus 1 plus gamma by 1 minus gamma. Gamma is reflection coefficient. In the question, they have mentioned reflection coefficient as tau. 1 plus tau by 1 minus tau. And reflection coefficient tau is equal to ZL minus Z0 by ZL plus Z0. Propagation constant gamma is under root R plus J omega L G plus J omega C. Characteristic impedance Z0 is under root R plus J omega L by G plus J omega C. It is not L, it is C. Therefore, correct answer is A4, B3, C1, D2. Option 2 is the correct answer. Next question, question number 123. Response of ideal filter is mentioned here. For low pass filter, it is lower cutoff frequency is 0 and higher cutoff frequency is FC. For high pass filter, lower cutoff frequency is FC and higher cutoff frequency is infinity. For band pass filter, lower cutoff frequency is FC1, higher cutoff frequency is FC2. Similarly, for band stop filter, cutoff frequencies are FC1 and FC2. For ideal low pass filter, up to cutoff frequency, all frequencies are allowed with zero attenuation. If frequency is beyond higher cutoff frequency, attenuation is very high, almost zero signal is transmitted. For high pass filter, up to cutoff frequency, attenuation is maximum, that is stop band. Beyond FC, it is pass band. For band pass filter, between FC1 and FC2, all the frequencies are allowed. The frequencies below lower cutoff frequency is attenuated and the frequencies above FC2 is attenuated. For band stop filter or band reject filter, the frequencies below FC1 is allowed and frequencies beyond FC2 is allowed, but within the frequencies FC1 and FC2, it is a stop band. No. So low pass filter is very small gain at high frequencies, that is low pass filter. Next, high pass filter is high gain at high frequencies. Band pass filter is high gain at for a band of frequencies. The gain is very high for a particular band of frequencies, that is high pass filter. Band pass filter is high gain for band of frequencies. Band pass filter. Band reject filter is very small gain per band of frequencies, that is band reject filter. Correct answer is A2, B1, C4, D3, option 2. Question number 124. A type 4 interrupt represents. So an interrupt is a condition that halts a microprocessor temporarily to work on a different task and then returns to its previous task. Type 0 interrupt corresponds to division by 0. Type 1 interrupt is used for single step execution for debugging the program. Type 2 interrupt represents NMI and it is used in power failure conditions. Type 3 represents breakpoint interrupt and type 4 represents overflow interrupt. Correct answer is option 2. This type 4 interrupt represents overflow interrupt. Question number 125. For a Bode plot of a system to be stable, we know that the Bode plot stability is determined by analyzing gain crossover frequency and phase crossover frequency by using gain margin and phase margin. A system is said to be stable if phase crossover frequency is greater than gain crossover frequency or if both gain margin and phase margin are positive. If gain margin and phase margin is positive, then it is a stable system. If gain margin and phase margin both are 0, it is marginally stable. Either gain margin or phase margin is negative, the system is unstable. Let us see the statements. Phase margin and gain margin should be positive. Statement A is correct, then the system is stable according to the Bode plot. Statement B, phase margin and gain margin are negative, it is positive. Statement B incorrect. Statement C, the stability of system is independent of gain margin and phase margin, incorrect. Stability of a system is dependent of gain margin and phase margin. Correct statements are A and D and correct answer is option 3.